Hi everyone, let's go through week 11 tutorial activities answers. Now in this week, we are focusing on agile system development methodologies. Okay. So the first question is, what is an agile development? So agile development is a philosophy, and we can say it's a set of guidelines for developing information systems in an unknown, rapidly changing environment, and it consists of a statement of core philosophy and set of values or guidelines for how we're going to build models. So that is what we mean by the agile development. Question 2 is asking, what are the four values reflected in agile development? Now if you have gone through my lecture in previous week, I have discussed some core basic values. There are four basic values of the core agile philosophy, right? Based on. So, what are these four values? The first value is value responding to change over following a plan. So, what does it mean? It actually tells us rather than focusing on planning or emphasize on planning too much, focus on the change that it brings by that particular project. So responding to a change is more important than strictly following a plan. That's the first philosophy tells us, or first the first value tells us under the agile development. The second value is value individuals and interactions over processes and tools. So what it means is it actually promote all the development teams to interact with not only with the users and the other stakeholders, but also interact with themselves to build a proper working solution for a given problem. So the individuals and the interactions are more important than following the processes and other tools. So that is the second value under agile development. And the third value is value of working software over comprehensive documentation. So what does it mean? It actually promotes to build a software, right, rather than developing or building more and more documentations or focusing on documentation. Work on actual piece of software. That's what the third value actually focusing on. And then the fourth value is value over customer collaboration over contract negotiation, right? So that's the fourth value. Okay. So what does it mean? Involve the customers more rather than focusing on the negotiation of with the customers to sign up the contracts. So these are the four agile values. So first value is value responding to the change over following a plan. Second value is value individuals and the interactions over processes and tools. And the third value is value working software over comprehensive documentation. And finally, the value the customer collaboration over the contract negotiation. So these are the four values under agile development. The third question is, what are the four UP stand for unified processes? So what are the four unified process phases and what is the objective of each? Right. So if you go through my lecture slides, I have discussed four phases under unified processes. Okay. The first phase is the inception phase. The second phase is the elaboration phase. The third phase is the construction phase. And then the fourth phase is the transition phase. So the inception phase actually try to understand the overall scope and the objective of the system. So basically, the focus is to make a business case. How are you going to solve the problem, or how are you going to grab the opportunity, right? and also it focuses on how we going to get it approved from the higher stakeholders, right? And also it also kind of a try to make a kind of a estimate how the project looks like and how much it will going to cost and what is the schedule that we need to follow, right? So all these stuff comes under the inception phase under the unified process. So the second phase is the elaboration phase. It's basically that phase, the projects try to identify and describe all the requirements to finalize the scope and the design and the building of the core functionality. So all these things comes on the elaboration phase. So basically requirement identification, finalizing the scope, designing and building the core functionality to the subsystem, and also to address the major risk of the projects also undertook by the elaboration phase, right? And then the third phase is called construction phase. Okay, so under the construction phase, the focus is to finish building of all the components of the new system and prepare the system to deployment. Okay, so that's the construction phase focusing on. And then the last phase is a transition phase. So the transition phase is basically focus on the testing side of how to complete the testing of the new system and converting the data into the new system, and then finally deploy the system as a working software, right? That's what the transition phase looking at. So these are the four unified process phases: inception phase, elaboration phase, construction phase, and the transition phase. So the question number 4 is focusing on the extreme programming. That's the second agile system methodology we discussed in our last lecture. Why is the word extreme included as part of the extreme programming? Now, the fundamental idea of extreme programming is to take the very best principles and practices of iterative development, or in other words, agile development, and implement them in a very extreme or in very best manner as possible, right? And focus on those practices intensively. That's what the extreme programming means. So we take the best practices in the software development, we take that best practices to more extreme phase, right? That's what we mean by extreme programming means. And the question number 5 is asking list the core values of extreme programming. Okay, so like in other agile projects or agile development methodologies, extreme programming also has some core values. So what are these core values? So basically, uh, there are more core values, but there are 4 core values are more important than anything else. So first core value, the important core value is the communication, right? So communication, that means we need to ensure that open and frequent, accurate, complete communication between various stakeholders, especially between the project members or the programmers, right? And between the users and the project uh, um, uh, in a frequent basis. That's what we mean by the first core value tells us. The second core value actually tells about to build a simple solution. This is called the simplicity, right? So we need to build a simple solution and adapt a simple approach to build the solution. In other words, simplify all these code development methods, right? Rather than we have a complex system, make very complex, and when the users and even for the project members sometimes it's not worthwhile to put an effort on the complex systems. So that's what do you mean by the second principle or second core value says simplicity. The third one says the feedback. Um, so what do you mean by the feedback is it says we need to establish procedures to promote a rapid feedback from the users and the other developers, right? So if you have gone through that feedback process, I mean the last week lecture, you may have noticed that feedback is one of the important thing in under the extreme programming. Okay, so because the reason is we need to change or quickly modify errors that we have detected as soon as possible. Okay, and then the last core value or the value under extreme programming is called the courage, right? So we need to have a courage to do right things even if there is a price to pay. Okay, as a software developers, we need to have courage to change what we have done so far, right? So it can be a piece of code we have written, right? So we should able to change it, and we should able to think that code is belongs to the group of people or the team, not for the me, right? So likewise, there are four core values: communication, simplicity, feedback, courage. These are the four important core values under extreme programming. The question 6 is asking about, now it's actually focusing on the third agile um, project methodology that we have learned last week. It's about Scrum development methodology, right? So it's asking a question: what is the product backlog used for in a Scrum project, right? So if you have gone through the last week lecture, you may have noticed this. What do you mean by this product backlog? So basically, the product backlog is where the requirements are identified and documented, right? So the requirements need to be prioritized on this product backlog, and then the list is going to use to select, going to select the requirement for the software project or the project, right? So we first build the document all these requirements in the product backlog, and then we prioritize it. Then we'll take the highest prioritized listed items to development purpose, right? I mean, we call this a sprint, right? During the next sprint, right? So each sprint working on or the focusing on kind of top prioritized items in the product backlog, right? So the product backlog is controlled by the user or the stakeholder who is, I mean, we can call it them as a sponsor, right? So who is sponsoring the project is looking after this product backlog, and he or she decide what is on the list and what are the priorities are in the project at the moment, and he or she need to works with the a project manager in that particular Scrum project. We call it as Scrum Master, right? So we don't call actually project managers in the Scrum project. We call Scrum Master. So then they will decide what can be implemented in the next iteration, or in other words, in the next sprint, right? So that is the whole purpose of the product backlog. So it's a prioritized list of requirement items. Okay, so that is what we mean by product backlog. So the next question number 7, is again asking something about the Scrum projects. So this time they ask us to explain how a Scrum sprint works, right? So a Scrum sprint is a kind of a usual. It's a kind of a 30-day intense work. It's a time boxed uh, work activities, I would say, right? So usually the 30 days, right? That is what we call the Scrum sprint. um, so in that sprint, a particular part of the system is going to work out and then they implemented, right? A set of requirements are chosen from the product backlog and decided upon how to work in that particular sprint, right? And then the scrum team organize themselves and make the assignments as to how the sprint is to proceed, right? And then once they have decided that, the scope of the sprint is going to be frozen, so nobody can change the scope of that particular sprint, right? And then the time period also set, right? So 30 days we will do this particular items and that's it, right? So the every day during the sprint, the Scrum Master has shortly daily Scrum meetings where the developers report on what they have accomplished, right? Accomplished in terms of developing the project activities or maybe the use cases or programming, etc., etc. So what they have done in last 24 hours, right? And what they are going to be do in the next 24 hours, right? And what are the daily obstacles or roadblocks that are that impede their progress? All these three things, actually, these three things discussed in the daily scrum meetings, right? So at the end of the sprint, the identified requirement should have been implemented and deployed, and then the next sprint starts thereafter. So likewise, the product backlog items get implemented in the project in a systematic basis. So that is what do you mean by a scrum a sprint means and how it works. Right, so the question number 8 is asking, we are going back to these so-called iterations. Now remember the iteration in the system development activities. So question 8 is asking us to describe an information system project that might have three subsystems. Discuss how these iteration how three iterations might be used in the project, right? So iterations in this subsystem can be used in a different ways, right? So what do you mean by the iteration? An iteration can be considered as a mini project in that we often takes a smaller component or subsystem or maybe larger system, right? And we do analysis, we do design, and we do some sort of an implementation in that particular iteration, right? So if there are three subsystem and if they are small enough, each subsystem might be done in a single iteration, right? It depends, right? So large subsystem might require multiple iteration, but in this case, maybe if it is a small project, in each iteration we can focus on one subsystem, and within three iteration we can actually finish this subsystem, right? That's a one approach. Another approach probably, it depends on how complex or how risky the system is. So what we can do is more complex, more risky parts of the system, right, across the three subsystem can be handled in a first iteration, right? um, and then the some work should be done within each subsystem for other iterations, right, until we finalize. So the third iteration probably we can finalize um, finalize the project, right? So if you focus on the some parts in each iteration, in the first in the second and the third iteration, because then we can uh, uh, reduce the schedule dependencies, right? So we need not to actually wait until the other part has been worked, so we can complete the project simultaneously in three iterations. So that's the second approach or second scenario we can use the iteration, right? Okay. Okay, now we are moving to the last question, question number 9. It asking about again extreme programming. So consider extreme programming's team-based programming approach in general and its principle of allowing any programmer to modify any code at any time in particular. No other development approach or programming management technique follows this particular principle and why not? In other words, what are the possible negative implications of this principle? How does extreme programming minimize these negative implications, right? So I think I have discussed this in the last lecture. Now, you can actually give a different answers to this kind of question. So most people, including the developers, right, they will take the pride of ownership if they build or if they do the things. I mean, if they code the programs in a correct way, right, what they have created, right? Or sometimes they may will become very defensive if others find, okay, there are some mistakes or errors in your work, right? So we will getting kind of a, so if they tend to, I mean, it's a human nature, right? We will be more very defensive if something, someone find out some mistake, right? So in either case, most people do not actually like to have other people to review their work or change their work, right? That's the human nature, right? So it takes a kind of a sort of, it take little time to change this attitude in the people's mind, right? When you work in a kind of a group activity, so software development is almost a group kind of a work. So changing these sort of attitudes actually take time. So extreme programming, actually this XP methodology actually focuses heavily on the fact that the development is a collaborative team effort. So that's something the valued most in under the extreme program. It's a collaborative team effort, right? So the code or programming codes is kept in a kind of a common pool. The code is out for any person in that particular group, right? It's actually open. So in order to foment this kind of an attitude, we need to actually put little bit of care, right? Not to criticize the programmers or the developer, but to focus on making the code as rock solid as possible, right? That's the attitude we need to develop. How we going to actually most efficiently develop the code rather than criticizing someone, right? So that's the one of the key principle of value the extreme programming is based on, right? So there are several extreme programming practices emphasize this approach and help to set up atmosphere of kind of a atmosphere of cooperation and the collaboration. Okay. So XP practices include, I mean, encourage these attitudes by including several practices. There are few practices actually encourage this. So if you go through the lecture, I have discussed the pair programming practice is one that actually encourage most the kind of this sort of attitude. So there are two programmers work simultaneously. One is working on the programming and the other one is working on the design aspect. And then when the time passes, they switch their roles. So that is what we mean by the pair programming, right? So that actually give a kind of a sort of idea that okay, people, I mean, feel that people belongs. I mean, the teams belong the code, not for themselves, right? And then the second principle is simple design. Always need to simplify the things. Don't complicate the coding process, right? Simplify design. Simple design always promoted by extreme programming. And the third principle is refactoring the code, right? So we have to refactor the code, reuse the codes over and over again. Then in that case, we can actually make sure that the codes are developed more efficient as possible, right? Refactoring is the third principle. And the fourth principle is ownership of the code. So as I mentioned before, ownership of the code has to be collective, right? So it's a collective ownership rather than individual ownership. That's what we mean by the fourth principle. And the fifth principle is continuous integration. So when we develop a piece of code, integrate it to the existing system, and then we develop another piece of code, integrate it to the existing system. So likewise, continuous integration make the life easier, so we can develop small portion, testing it, and then they integrate it, right? If the test is passed, we can integrate it, right? That's one of the main characteristic of XP. And the last one that for most uh, influence in this sort of attitude is coding standards. So well established coding standards will give you a kind of positive attitude, how we going to develop the system or the code the systems to comply with these coding standards, right? So these are the XP practices that emphasize this attitude of XP programming practices, right? So pair programming 1, simple design 2, refactoring the code is 3, owning the code collectively is 4, continuous integration of the code to the existing system, and finally coding, implementing the coding standards. So these are the answers. These are the answers to week 11 questions.